Hey everyone, so in today's video we're gonna be talking about the alcohols, which are a very specific homologous series, which are the organic compounds that have a hydroxyl functional group. So hydroxyl functional group, which means OH functional group. Whenever there's an OH within the organic compound, it is likely to be an alcohol molecule. For example, methanol with one carbon and OH, ethanol with two carbon chains and OH, propanol with three carbons in the chain and OH group. Here, we're going to be talking about that alcohols can be prepared by two different methods. So we're going to be talking about the methods which we use to prepare the alcohols. There are going to be two of those. First method is going to be a little chemical process that we have already done. The second one is something new. First one is obviously the addition of steam on alkene. The second one is fermentation. So let's recall the idea of addition of steam, because this is the addition reaction on alkene. We have already watched videos about the addition of steam on alkene. For example, just hypothetically, I am having an alkene molecule which has apparently 4 carbon atoms. The fourth one is a branch. It is going to be isobutene because it has a carbon-carbon double bond, 4 carbons in total, and the third one is like this, there's a branch coming out from the middle. So it's isobutene. We know when addition of steam happens, the same structure is used, but we do one thing, that we remove the carbon-carbon double bond, and then we add H on one of the carbons, and then we add OH on the other carbon. So we get alcohol molecule. This method, because the idea of addition of steam happens on those carbons, so this method can produce any alcohol that we need. We just need the alkene and we get the alcohol. So using its alkene, for example, ethene could give us ethanol, propene can give us propanol, butene can give us butanol, so on and so forth. So we can have addition reaction with multiple alkenes. But there's a disadvantage of this method. It requires 300 degrees Celsius, which is a high temperature. And obviously, in order to reach that high temperature, we need to burn a lot of fuel. So high temperature requirement and fuel consumption happens. So fuel consumption, because we are going to burn a lot of fuel. So it adds to the cost. It costs a lot to produce that much heat, because we need a lot of heat. Plus carbon dioxide is released when we are burning the fuels, which is also a problem for the environment. So carbon dioxide is also produced. Let me turn it. The other method is fermentation of carbohydrates. We know carbohydrates are a biological molecule, which is starch, sugars like glucose, fructose, galactose. These are all sugar molecules. Or starch or glycogen are again carbohydrates. So this is a biological process going on. Glucose particularly has a chemical formula of C6H12O6. In the method of fermentation, what actually happens is we deal with yeast, which is the name of a fungus. We take a round bottom flask. I am drawing the round bottom flask over here. Then obviously we take a sugar solution. We take the solution of a carbohydrate. We make sure there's a rubber bung on top of the round bottom flask. We'll see why it happens. We have a round bottom flask. We have our sugar solution, which involves perhaps glucose solution. Then there is a rubber bung on top of my round bottom flask. Why do we have it? Because we do not allow oxygen over here. We'll see why it happens. Then at the bottom we have yeast, which is a microorganism fungus. Yeast suspension means the cells of that microorganism fungus. This process happens in the absence of oxygen. what happens is that the glucose molecule, which is C6H12O6, in the presence of yeast and in the absence of oxygen, I repeat, in the absence of oxygen, it gives us 2 molecules of ethanol and 2 carbon dioxide molecules. So we get 2 carbon dioxide after the fermentation of each glucose molecule. So you will be seeing when carbon dioxide releases, you'll be able to see bubbles of carbon dioxide coming out from the suspension. So these are the bubbles of carbon dioxide coming out, and obviously this indicates that the process is going on and you are receiving the carbon dioxide as well as the ethanol molecule. So this process involves the fermentation of glucose to give us carbon dioxide and ethanol. Let's revise the idea of fermentation. Fermentation is a biological process where yeast, which is a microorganism, it's a living biological organism, yeast microorganism is required. Then we know 25 degrees Celsius is needed because yeast is a microorganism, it might die in high temperatures. We need anaerobic condition, which means no air or no oxygen. We make sure there is no availability of oxygen, and in biology we call it anaerobic. We need a carbohydrate solution, we need glucose or starch or anything to begin with. These are the basic conditions of the fermentation process. What is the disadvantage of making ethanol through this process? The disadvantage is that obviously carbon dioxide is getting released. So you produce carbon dioxide, it produces only ethanol. Number one, this is the problem over here, that it only produces ethanol. You do not get all the alcohols. You cannot make propanol, you cannot make butanol, you cannot make pentanol or anything. And the other problem is that it releases carbon dioxide gas only. So carbon dioxide gas is a greenhouse gas which is problematic for the environment. So let's revise the idea of the 2 processes of making alcohols. First process is the addition of steam and the other is fermentation. Both processes are really different and let's compare them. In the addition of steam we need alkene and steam, but in the other process we need a carbohydrate and yeast. In the addition process, it is a chemical process, not a biological one, but fermentation is largely a biological process. Addition process requires a 300 degree temperature, but fermentation needs only 25 to 30 degree of temperature. Addition process can make all the alcohols possible, but fermentation can make only ethanol molecule. So these 2 processes can be used at our own convenience, and in the next video we're going to be talking about more on the alcohol oxidation. So I hope I'm clear to you guys. Stay tuned guys.